Mechanical and microstructural properties of fly ash-based geopolymer concrete incorporating with bagasse ash and metakaolin. Abstract: in this experimental study, the bagasse ash and metakaolin is used to develop the geopolymer concrete. The fly ash-based geopolymer concrete was prepared with bagasse ash and metakaolin, which were used to replace fly ash at different percentages, i.e. 10%, 20%, 30%, and 40% to study the microstructure, mechanical and durability properties. Geopolymer concrete was prepared with the use of alkaline solutions NaOH and Na2Sio3. Geopolymer concrete samples for bagasse ash and metakaolin based were cured at oven for 24 hours at 90 degrees Celsius and then kept under room temperature for curing. Metakaolin contained geopolymer concrete has shown better mechanical and durability properties as compared with bagasse ash contained geopolymer concrete. Geopolymer concrete is raw material based concrete that leads to the usage of materials which are produced as a raw material from industries, and when these raw materials were induced in the geopolymer preparation, it leads to the reduction of carbon emissions and acts as a greener concrete towards environment. Microstructure studies concluded that the metakaolin contained geopolymer concrete has denser intermolecular bonding of materials as compared to the bagasse ash contained geopolymer, due to which metakaolin shows better results in mechanical and durability properties when compared with bagasse ash. Keywords: geopolymer concrete, fly ash, bagasse ash, alkaline solutions, metakaolin. Introduction. Concrete is the world's most versatile, durable, and reliable construction material. Next to water, concrete is the most used material, which requires large quantities of Portland cement and aggregates. It is reported that the consumption of cement in India is 421 million tons and likely to touch 550 million tons by 2020, and global cement consumption is 4.0 billion tons and likely to touch 4.2 billion tons by 2020, Department of Industrial Policy and Promotion. On the other hand, the demand for construction aggregates in India amounted to 1.1 billion metric tons in 2006, making the country the third biggest aggregates market in the Asia-Pacific region and fourth largest market in the world, after China, the US, and Japan. Sales in India have risen an average of 7.7% annually over the past 10 years, exceeding both regional and the global demand for construction aggregates is expected to grow 4.7% annually through 2011 to 26.8 billion metric tons, Indian Concrete Institute. Early pace of construction is increasing day by day, which is leading towards the increase in carbon dioxide, CO2, emissions, which is basically released by the production of ordinary Portland cement. Concrete use over the world is well known, and the increasing construction work has led to introduce such type of substitution or alternate material which will help to increase the pace of construction by early strength property and reduction the carbon emissions as well. The properties of geopolymer concrete for fresh and hardened concrete depends upon the type of materials that has been used for the preparation of geopolymer concrete. The durability of property of geopolymer concrete is better than the conventional concrete due to the high composition of chemical compounds, and due to this the thermal resistance of geopolymer concrete is better substitution for the ordinary conventional concrete. It has been observed after studying the geopolymer concrete it showed the eco-friendly and greener properties towards the environment and better engineering properties. 11, 12. The use of eco-friendly material in concrete will help in many ways, such as dumping of tons of waste will be utilized. 2. Literature review. There is a wider area of concern that has to be filled by doing research on geopolymer concrete with bagasse ash and metakaolin replacement with fly ash and ground granulated blast furnace, GGBS. In this research the various percentages will be checked with fly ash and GGBS replacement with bagasse ash to check the geopolymer concrete properties for various tests, and then fly ash and GGBS will be replaced by metakaolin for different percentages to check the various tests conducted on concrete to see its strength, i.e. compressive strength, flexural strength, split tensile strength, sulfate attack, abrasion test. The work done with geopolymer concrete with fly ash replacement with bagasse and metakaolin has a broad area to work with, and geopolymer concrete is future concrete, so there is a gap in the research related to geopolymer concrete, and by the use of such replacements we can check the geopolymer concrete properties by doing testing on it. Using such replacement with fly ash and GGBS will give an idea that up to which percentage the replacements can be used so that we can get the results in desired values. 3. Material used. A. Fly ash. Fly ash is byproduct, which is waste product which is obtained from the thermal power plants, and it is a mineral admixture. Fly ash was obtained from the Ropar thermal power plant of class F. The specific gravity of fly ash is 2.35 g/cc. B. Ground granulated blast furnace slag, GGBS. GGBS is a ground granulated blast furnace slag particle which is obtained from the steel manufacturing plant. GGBS is a powder form, can be replaced with fly ash. GGBS is kept constant with the 20% replacement with fly ash. GGBS specific gravity is 2.7 g/cc. See bagasse ash, Ba. It is a waste byproduct of sugarcane industry and it is obtained after the burning of sugarcane. It is in ash form which was obtained from the Marinda sugar mill. It has specific gravity of 1.13 g/cc. D-metakaolin. Metakaolin is having high reactivity, silica-based pozzolana. It is manufactured by the processing of specially selected pozzolanic ingredients under controlled conditions. It is form of a kaolite which is a clay mineral which has excellent cementitious properties. It is a clay mineral which is off-white in color and has a specific gravity 2.6 g/cc. E. Fine aggregates. The locally available river sand used as fine aggregates of size less than 4.75 mm. F. Coarse aggregates. The aggregates having size greater than 4.75 mm called as coarse aggregates. The locally available coarse aggregates having size 20 mm used. The shape of the coarse aggregates was rounded. G. Alkaline solutions. These solutions are used with the powder to mix it and prepare the geopolymer concrete. The solutions are used in ratios. The NaOH and Na2Sio3 are used in 1:2.5. The 12 m of molarity is used for NaOH and the Na2Sio3 is used in the form of liquid of A53 grade which has 59.5% of solid content in solution. Sodium hydroxide flakes were used in the study and NaOH used is of commercial grade with 97% purity. H. Water. Normal tap water is used for fulfilling the demand of solid content present in the alkaline solutions. The use of water is less in geopolymer concrete. I. Superplasticizer. Superplasticizer Compost SP430 was used as a chemical admixture for concrete. Images of used materials shown in Figure 1. 4 Results and discussions. In this section results has shown from Figure 2 to Figure 5 and also tabular results highlighted from Table 2 to Table 5. A. Compressive strength test. Compressive strength testing is done to determine the strength of the concrete by casting cubes of size 150 x 150 x 150 mm to determine the strength of concrete for defined grade. It is a mechanical test for concrete. The cubes are tested according to IS 516-1959. In Table 2 and Figure 2, compressive strength at 28 days is presented. T. B. Flexural strength of beam. Flexural strength is calculated to measure the flexural strength of concrete by casting beams of size 100 x 100 x 500 mm. Detail results of strength of beam at 28 days shown in Figure 3 and Table 3. C. Split tensile strength test. Split tensile testing is also the mechanical testing and it is used to calculate the split tensile strength of concrete. The size is 150 mm diameter and 300 mm length of cylinder is used to calculate the strength. Results of split tensile strength at 28 days shown in Figure 4 and Table 4. D. Sulfate attack test. Sulfate attack test is related to the durability property of concrete in which we immerse the concrete sample in the acid to check out the weight loss of the sample and how much reduction in strength has occurred. 5% of the weight of water acid is used for testing the sulfate attack and size of cube was 150 x 150 v 150 mm. The samples are cured for 28 days and then immersed in the acid for 28 days, 56 days, and 96 days to check the ability of concrete in acid environment. Further sulfate attack test at 28 days shown in Figure 5 and Table 5. V. Conclusion. 1. Geopolymer concrete has shown good mechanical and durability properties for designed grade of geopolymer concrete with metakaolin contained geopolymer concrete as compared with bagasse ash-based geopolymer concrete. 2. Metakaolin at 20% replacement and bagasse ash at 10% replacement have shown the maximum mechanical and durability result for geopolymer concrete. 3. Bagasse ash at 10% replacement has shown the optimum percentage for best results for geopolymer concrete. If we add the more percentage for bagasse ash it shows a decline but higher percentage of bagasse ash can be used to produce the lightweight concrete. 4. Geopolymer concrete is prepared with the use of raw materials which is eco-friendly and it will act as a green material to the environment. 5. Oven dry samples and normal temperature samples results were compared and in case of metakaolin the normal curing samples achieved the required strength of grade M25 but oven dry samples attained more compressive strength. Normal temperature curing for metakaolin contained geopolymer has attained 26.93 MPa strength, and in case of oven dry samples strength attained was 30.75 MPa.